Hello friends, this question is from the subject of networks and topic name is RLC circuit. It's a link data question. In a problem, it has been said that you need to consider an RLC circuit with the value of resistor as 100 ohm and capacitor as a 2.5 nanofarad. In the first part of the problem, question says that the value of omega n for the circuit to be underdamped is. For an underdamped circuit, we need to find out the range of omega n in the first problem. So we know that for an underdamped system, system, our damping factor delta is which is equal to R by 2 under root of C by L is less than 1. Delta is less than 1 for underdamped system. It's theoretical fact. And for the series RLC circuits, we know that 2 delta omega n is equal to R by L. So again a standard, that is delta is equal to R by 2L omega n, which is of course equal to 1 because delta itself is less than 1. It should be also less than 1. And similarly, we have also known that omega n is equal to R by L, but omega n is a resonance frequency which is also equal to 1 by LC, which means that my 1 by L is equal to the omega n square C, which is a second representation of the same equation. This term said the omega n is greater than R by 2 omega n square C. It is because if you put the value of 1 by L in this expression, in place of 1 by L, if you consider this expression here, it is 1 by L times R by 2 omega n less than 1. So in place of 1 by L, if you put the omega n square C times R by 2 omega n less than 1, it become that if you shift the omega n in this side, so you will get this expression omega n is greater than R by 2 times omega n squared C. So if you again rearrange this expression, it will be like 1 is greater than RC by 2 omega n, or you can again rewrite this as 2 by RC is greater than omega n, or omega n is less than 2 by RC. So now if you put the value of R as 100 ohm and capacitor C as 2.5 into 10 raised to the power minus 9 farad, so my omega n will be 2 upon 10 square into 2.5 into 10 raised to minus 9, which is omega n is less than 8 milliradian per second. Omega n is less than 8 milliradian per second. So for first question, my correct option is option B. Omega n is less than 8 milliradian per second.